Hello, everyone. I am delighted to introduce our next session, Shaping Humanity's Long-Term Trajectory with Toby Ord. There'll be about a half-hour talk and then a half-hour for Q&A afterwards. So if you do have questions while you're watching the talk, then submit them on the Swapcard app and thumbs up other questions that you'd like to see asked. Our speaker for this session is Toby Ord. Toby is a philosopher at Oxford University, founder of Giving What We Can, co-founder of the Effective Altruism Movement, and author of The Precipice. His work focuses on big picture questions facing humanity. What are the most important issues of our time, and how can we best address them? Please join me in welcoming Toby.
Hi. So today I want to talk, it's a bit more of a technical talk. I think the last couple of times I've been talking about big picture ideas in various other contexts. But every now and then I'm trying to get down to some technical ways of thinking about the big picture future, and that's what this is. And this is a talk about humanity's long-term trajectory. And ultimately, it's a talk about long-termism and how to make sense of it. So the idea of the long-term trajectory of humanity is that I want to try to develop a framework to think about how humanity's story might play out over extremely long spans of time. The idea is that humanity's been around for about 300,000 years. An average species would live for about 1 million years. So there could very easily be hundreds of thousands of more years at play. The Earth will remain habitable for about 1 billion more years. And there are species that have lived for 500 million years. That's not impossible. And so there could be spans like this available in the future. And one of the key ideas that I've talked about and others is existential risk, that whole future might be at stake. There might be ways that we could lose it all. For example, if humanity were to go extinct and have no role either in producing value within itself or in helping other species over that time. But there could be other ways that we could shape the long-term future where our actions could have influence over very long spans of time. And the idea of long-termism is to think about this broad class of ways that the future could be shaped. But most of that attention has been on existential risk. And what I'm trying to do here through this framework is to try to create ways of speaking about non-existential risk ways of shaping the long-term future. There's a philosopher, Nick Beckstead, who called this trajectory changes. And I'm trying to look at this kind of idea. What Nick Beckstead, was to say that the interest in existential risk, through Nick Bostrom's work and others, had argued that there was a strong case that preventing existential risk could be much more important than many of the near-term things that we work on. But it didn't give a strong argument that preventing existential risk would be more important than many other long-term effects that we could have. Ultimately, because the effects would be permanent over all time, you kind of get to add up the benefit or cost over this huge span of time. But that might be true for various other kinds of effects we could have as well. And so this is trying to get into that. And just to, you'll see it's some small steps really, but to try to improve the ways of thinking about these things. So the idea of thinking about a long-term trajectory, there's been a few different ways of doing this that people have looked at. So here's one kind, and here's a diagram from Nick Bostrom's paper in 2013, where there's an idea of a trajectory as a state space, so some multi-dimensional space where the kind of current state of humanity is represented as a single point in that space, and then we take some kind of meandering path around that space. In this example that Nick's drawn here, it's a 3-dimensional space, and there's some dangerous areas, perhaps dangerous combinations of things in these parameters, and maybe one has to try to navigate around through it and find a safe trajectory to get to a good point within that space. that's one way to look at it. And another way that's been done is to think of a trajectory as a graph of something over time. In the previous version, the state space, time isn't really represented anywhere. Instead, you have a path of, a point, it traces out a path through time. But if you went the same path at a different speed, you would get exactly the same looking trajectory. And it's hard to talk about time. It's kind of a timeless way of presenting it. Whereas one advantage, perhaps, of thinking of it as a graph of something over time is that you can make more clear these questions about how quickly we proceed. And I think that's going to be one of the key types of change one can make to the future involves changing how quickly we get there. And it's easier to understand that and think about it with this kind of a graph. You can see from this one here from Nick Bostrom, 2009, that on the y-axis he's got technological development. And that's just, it's not even really a quantitative dimension. It's some kind of qualitative thing. And he's trying to sketch there that, that from this kind of, what's he call it, this pre-human condition, that there was some kind of ascent in technological development up to some kind of range. And then there's this question about will we burst through that range and reach extremely high technological capabilities, or will we perhaps have series of growth and then collapse but remain within that range, or will we crash down back to this pre-human level of ability upon the Earth? And so it's useful for expressing that type of question, but not for really making quantitative claims or thoughts about this. Here's another example that's quite similar from a paper, Baum et al., lots of co-authors from a big conference discussion that led to a massive paper. And it was similarly trying to think about different levels that we could be at, say, agricultural or industrial, and ways that we might crash down to a lower level and then perhaps find our way back up as, again, a qualitative framework. What we're going to be looking at here today is my approach to doing this, which is like these graphs. It's a single dimension over time. That's the kind of object that a trajectory will be. But unlike the others, I want to do it in a quantitative way. And what's going to be on the y-axis is the instantaneous value of humanity. So how valuable is humanity at that time? And then there's going to be a focus on the area under the curve, because if there's instantaneous value on the y-axis, then the area that's swept out by the graph will be the value that's achieved by humanity over time. I'm also going to focus a lot on comparing different trajectories. It turns out that sometimes it's actually harder to say something about what the future will be like or how valuable it would be, and easier to say something about what would be the change in that value if we were to make some modification. So we might not know how good it is, but we know it would be better if we did a certain thing, and we might know how much better, even though we don't know how good either of them actually are in absolute terms. And overall, what I'm trying to do is to give this framework that will allow people to think a bit better about non-extinction long-termist interventions, and to understand them, have a language for talking about them, and hopefully have a bunch of qualitative things that one can take home as lessons, and to produce that via quantitative methods. It's not so much that we're all going to go away thinking, now we know how many units of value there'll be in the future, or something like that. It's more that we'll understand whether one style of influencing the future seems more promising than another style of doing so. So another way to put that is to help understand, to classify, and to compare these long-termist interventions. So some examples of things that one might try to ask would be, how does reducing existential risk compare to speeding up technological progress, or in fact other kinds of progress? Or how does reducing existential risk compare to ending up in a better equilibrium over the long-term future, assuming we do survive? You could kind of think of some of this as this trading off where we end up versus how quickly we get there. These are the kinds of questions that this will hopefully help with. So here's the kind of thing that I'm talking about, a very stylized graph. What we've got is a curve of this instantaneous value over time. In this trajectory, you can see that the past is to the left of of the y-axis. And then humanity's instantaneous value is rapidly ascending, reaching a temporary peak and dipping down a little bit, and then reaching a higher peak, fading off for a while, and then we go extinct at the end of that. I guess it's not clear in this case exactly why we went extinct. Maybe that was we'd achieved all that we could, or reached some kind of final time where, say, the stars burnt out or something like that, and there was no more that we could do. Or maybe it was because we prematurely went extinct through a natural or an anthropogenic event. Either way, we've got this situation where, in this case, humanity's achieved a great amount of value over time. And there's, it's ultimately just mathematically the integral. So the area under this curve is the amount of value that would be achieved on this framework. And a useful way to think about this is that I've labeled a few points on this graph. The duration of our future I call tau. The value at the last moment I call v tau, v subscript tau. And the average value at all time, over all time, over all of the future times, I call v bar, so it's the average. And as I note here, the overall value that we would achieve in this way of looking at it is just ultimately equal to v bar times tau. And then that's kind of a useful way to think about things, because one could contemplate how long this future might be. You know, I said that it could easily be 1 million years. It would be for a typical species. And it could, I think, quite conceivably be hundreds of millions of years or billions of years or more. And so if we look at the time until most of the stars have burnt out, then we're talking around about 1 trillion years. So tau could be extremely long. And then v, or v bar, the average value at any time, could also be much higher than it is at the moment. I have a point v naught, which is the amount of value at the moment, drawn on here. And this is a very stylized graph, and you know the v bar only looks like it's about 3 times higher. Maybe that could be the case. Maybe we stay on Earth and maybe things get substantially better. A lot of the misery that has been produced is ended, and people's lives, let's say, are twice as good, and there's something along these lines. We could have a situation like this. But it's also conceivable that value that we achieve in the future at any one time could be much higher than it presently is. There are about 100 billion stars in the Milky Way galaxy. And you know, if we were to settle our galaxy, then just the scale of our civilization could be billions of times larger than it is at the moment. Now, it's debatable as to whether that is actually more valuable. Some people might think that it's not. They maybe would think that if a civilization lasts 10 times as long, that's 10 times better. But if it were to be 10 times as big at any one time, that doesn't count extra. Maybe that's right. If so, then maybe v bar is not actually all that much higher than the value at the moment. But it could well be wrong as well. I think it's entirely plausible that a galaxy-spanning civilization is substantially more important, perhaps even 1 billion times as important as a single planetary civilization. But these are just 2 ways in which the future could be a lot bigger. We can also try to think of that as, here I've tried to shade in, again schematically, the next 100 years. So this is the value of the next century to come. And the idea here is to think, how big is that as a fraction of all the value that there would ever be on this trajectory? And there's 2 ways to look at that. Again, there's the time, and then there's the value. And so one can do a bit of maths here and work out that the value of the whole future is this much better. V bar divided by v naught, which is the ratio of how much better are things on average than they are at the moment, which might even be as high as 1 billion in this example I gave if we reach this huge scale. And the duration of humanity's whole future compared to a single century, which again could be as high as 1 billion if we last 1 billion centuries, which is, there'll still be stars burning and so on at that point. I'm not making claims that we will achieve either of these things, but these are the kinds of numbers that are on the cards if you're actually trying to soberly take seriously how big the future could be. And it's very interesting to think of these as just these two quite different ways the future could be better. And then there are potentially long-termist interventions that act on each of these things. Some that act on value, some that act on time. And we'll see that. Okay, so most of the rest of what we're going to look at here are looking at 5 different idealized changes to humanity's trajectory and trying to understand what kinds of effects they would have upon it, and to try to build up a toolkit for thinking about these changes that we might make. I'm going to focus in these cases on marginal changes. I'm kind of assuming that the future here could be just very long compared to our lifetimes, such that I'm imagining that even if a change were that we might be able to implement might take a huge amount of time and effort, maybe take centuries of building international agreements and things in order to achieve it, that would still look like a very short amount of time compared to this duration that we're looking at. And so I'm modeling that as a change that happens all right now. And because these things are so large, like these spans of time, billions of years and so forth, if you're thinking of, say, accelerating progress such that we advance progress and get to each point earlier, I'm imagining that the amount at which we do that is small compared to the entire future. It's not that we advance progress by 500 million years or something like that, but maybe we could advance progress by 1 year in a world that's going to last much longer than 1 year. In which case the mathematics simplifies. You can make a bunch of assumptions if you're dealing with these changes that are relatively small compared to this huge big picture. And we're going to look at 5 different kinds of idealized change. What I call advancements, speed-ups, gains, enhancements, and risk reductions. And risk reductions we'll come to at the end, but that's basically the one you already know about. Okay, so I think one of the most interesting is advancements. So here is a trajectory of the future. And now imagine that there's something that we can do in order to work on progress. And in this case, it would be kind of progress across the board. So we would we're modeling this as thinking that we'd get wherever we were going, but we'd get there a bit sooner. There's actually, in English, there's not a great name for this. And I think there's a great name for the opposite idea, which is a delay. You could imagine delaying progress by a year, and you can kind of intuitively understand what that means. I'm using advancing or advancement to mean the opposite of that, bringing it earlier by a year. Sometimes people in this community have tried to use the term speed up for it, but as we'll see, I think speed up naturally as a term refers to something else. If you're thinking kinematics, that we're changing the displacement here, not the speed. Yeah. Okay, so let's imagine that we do something that kind of brings this forward, so we get everywhere a bit sooner. So it's this change by some amount that I call delta t in this curve, where now we're going to go along this dashed curve. And when you do so, something pretty interesting happens, which is that if the value of the world is getting better, if things are overall getting better, maybe the bad things are getting smaller, maybe the good things are getting more good, then bringing things sooner isn't just a matter of impatience or something. It's not just that we can't be bothered waiting until these good things will come. But actually, things you can see during this time at which things are getting better, reaching these better stages sooner just kind of means it's better at all of those times than it would otherwise have been. And if the whole trajectory were just sweeping upwards and there was no turning points, then in fact, moving things earlier would just make all times better. And you can see on here that the amount by which it would make it better is equal to the area between these two curves. So you could look at all the area under one curve and all the area under the other curve and subtract them. I don't know what the area under these curves is going to be, but it turns out that in that case, there's a big kind of unknown that cancels out, and all you end up caring about is the area between the curves. I've shaded some of the parts green and some of the parts red. The red ones get subtracted off. They're the areas where the changed curve is worse than the original curve. Okay, and so what we'd want to do in order to work out how much better it is if we advance progress like this is to estimate this area. And that might look a bit tricky to do, but there's a very nice simple argument that shows you what's going on. So consider this diagram here, where we've broken it up into three pieces, A, B, and C. And what you get before we do the advancement is that the future is going to consist of A followed by B. And then if we instead did the advancement, then in this example, the future would consist of B followed by C. So if I just go back a slide, you can see that I'm imagining in this case it will finish at the same time regardless. So the issue is, do you want A and B, which is the status quo, or do you want B plus C? And the difference between those two, it's clear that B is going to cancel, and that all you do is if you do the advancement, you lose A and you gain C. And so the value of the enhancement is just the difference between A and C. And if these amounts of times are marginal, if they're small compared to the total amount of time, you can kind of ignore the little triangular bit on top of these things and just treat them as rectangles, because that bit will be small. And then you end up with this kind of picture here, which is to say that the area, the difference, is just equal to a rectangle whose bottom is at v naught, whose top is at v tau, and whose width is delta t. So this is an example of how applying this kind of framework, the thing kind of simplifies out. And if you could just generally advance progress across the board, getting to all of these points earlier, that's the value you would create. Okay, I should pause for a moment to say that this involves, we're not doing any discounting in the normal economics-y sense. And most non-economists are not excited about discounting anyway, but just in case there are some economists here, to clarify, I think there are good reasons to discount financial benefits that happen later, partly because people are often richer due to growth, and they're diminishing returns on that extra money that they had. And you need to adjust for that, and that's one good use of discounting. And I think that the main valid reason for discounting the future, in terms of discounting the actual value that's created, not discounting the dollars, because dollars in the future are worth less than dollars now, but discounting the value to people, would be if there's a reduced chance that we even exist at that point in order to get those benefits. So i.e. to discount the future based on the risk, or on the probability of getting there. And I think that ultimately you want to build that explicitly into the model, and that's the way to do it. I'll say a little bit more on it later, but basically that there isn't discounting going on, and that's the reason that we treat that slice A and the slice C the same way, instead of saying because C comes so much later in time, we just ignore it. In general, in economics, there's enough discounting going on, they just add this exponential dampening effect on the whole future, that they don't have to ask these kinds of questions. Even if for some of our actions that have proximal effects and then these very long-term effects, the long-term effects basically are just set to zero by the equations that they use. And what we're trying to do here is to say, what if we didn't artificially kind of like dampen them down, and we actually just tried to see what kinds of systematic effects they could make? Okay. So I mentioned before that I was assuming that there was a kind of constant exogenous end time. Perhaps the stars burn out or something, and the question is how much value can we accrue before we reach that end time? It could be instead that if you advance progress, as well as moving the whole trajectory earlier, you advance the end point. For example, if it's an anthropogenic extinction event, such as, say, nuclear weapons, if we had advanced things, if people had tried to make progress go faster back in the Renaissance or something like that, maybe they would have been bringing forward the end time as well. If so, the calculation's a bit different. It turns out that in one case, you've got A plus B, and in the other case, you've just got B. You never get C. And so if that's the case, then advancements are just always bad, actually. And I think that that's quite an important point if you're thinking about advancing the future, is you really have to know whether this is the kind of thing that advances the endpoint or not. If it is, you actually just don't want to be engaged with that. You only want to engage in the types of advancements that wouldn't bring the endpoint earlier as well. So we can go more quickly through some of these other techniques. Here are speed-ups. The idea here is that instead of moving this curve across by some unit, we compress it down. So here we've sped everything up by some factor, which I call gamma t. And so then we've got a new dashed curve, and the value of doing that is again the area between the curves. It turns out that it's equal to this height times the width of that is I guess it's gamma t is like some number. I think I've made it so that it's greater than 1, and so it's like, say, speeding it up by 1% corresponds to dividing by 1.01, and then the width of this rectangle will be like 1/100th of the duration of the future. So, but you can ultimately, produce the equation that shows you the area for that, and it's simpler than you'd think. And I should say, in both those cases, there's so many ways we could have this trajectory go, right? And so many people might think, look, Toby, there's just no way you can predict the shape of this trajectory over time. And what's interesting is if you're looking at these idealized changes, you don't have to predict the shape of the trajectory over time. It's only these few parameters that I've mentioned, tau, v bar, v tau, and v naught. They're the only things that have any effect on the value of these interventions. The rest of the shape is entirely irrelevant, which is quite interesting. So you actually don't need to know it in order to be able to talk about this. If your speed up was done where there was going to be an endogenous end time, so for example, anthropogenic risk, then again, if you get everywhere 1% sooner, then you just have 1% less of a future. And that just ends up being bad as well. So like with the other case. Here's a slightly different one where instead of moving the curve to the left, we move it up. So I call this a gain, and the idea is there's some fixed amount by which we're improving every year in the future. I actually think this is one of the least plausible of these style of things, but it's useful for completeness. So we just shift it all up by some amount delta v. Every year or moment is better by that amount. It's perhaps easier to think of the opposite, a loss. But then you might imagine, for example, that destroying a particular ecosystem could be a fixed level of badness in all future time periods. Over the entire time that ecosystem could have existed. So something like that can be a bit easier to think of. And the idea here is, that when I say it's fixed, is that it doesn't scale with the size of the future. It's not that if the value of the future is either because of improvements to society or to do with the scale of the civilization, that the gain or loss would stay the same size over time, regardless of how big everything else is. Or alternatively, you can do the stretching in a vertical direction, which I call an enhancement. So for example, every time might be on average 1% better. And I think that's a little bit more plausible. So for example, if it turns out that certain values that guide the future get locked in at some point in time, it might be that they, for better or worse, kind of ossify and no longer are really open for change. Then it could be that those values could, that acts that one takes in the lead up to that could lead to some better values being locked in over those times. And that might have a kind of multiplicative increase in the value at any time that we achieve. Okay, and then risk reduction we can talk about as, it's hard to draw on the same diagram, but you can imagine just that there's a chance we have that future, and there's also a chance that we get nothing, that sometime near the present time, it just goes to 0 and stays at 0. And so the way I'm trying to represent this is that we've got a certain survival probability, P. Maybe that's, I guess in my book I would say it's like 5/6 or something of surviving through the century. And then we increase that from 5/6 up by some factor. Maybe we make it 1% higher than it would otherwise be. And that's another way of affecting the future, okay, where it increases the chance that you get this whole region below the curve. Okay, so here are all of those different things. And I've actually just written up here the equations, which are for what I have as delta V, which is the change in the overall value of the future by doing this thing. And they all, as you can see, only depend upon these few variables that I mentioned. They don't depend upon any details about the shapes of the curves. And then once you've got these things, you can start to actually ask some questions. So for example, you could notice that only enhancements and risk reduction depend upon both the average value of the future, which is one of the things I said could be absolutely huge, and also on the duration of the future, which is another thing I said could be huge. The other three only depend on one or the other of those two things. And so if each of those things could be a factor of 1 billion bigger than events today, and you only vary with one of them, you might have trouble competing with these things that vary with both of them because they get to be 1 billion times important. You can also ask individual questions. For example, you could say, in what circumstances does an advancement beat a gain? And you can just look at the algebra, and I'll work through a couple of these. But in this case, an advancement is better than a gain when this thing here on the left is bigger than this thing on the right. And you can rearrange it into a way that actually makes some sense. And it says that, it's actually kind of obvious once you do the rearrangement. It says that an advancement is better than a gain when the fraction by which you're advancing of the long-term future, so if the future is 1 billion years long and you're advancing it by 1 year, then your fraction would be 1 billionth. When that fraction is bigger than the fraction by which you're increasing the value at any time. So it ends up being not to do with the absolute sizes of these things in their units, but the relative sizes of them compared to these references. So that second one is the fraction of value you're increasing compared to the difference between value now and the value at the end. You could also try to compare, say, gains and enhancements, and you end up with something saying that it's this thing on the left here, which is like, so if the enhancement was by 1.01, a factor of that, then this thing on the left will be 0.01, like 1% improvement factor. It's when that's bigger than how the gain was as a fraction of the average value at all times. The important thing to notice there is just that there's no tau in either of those things. So there's no dependence on the duration of humanity's future. So even if we're ignorant about some of these variables like tau, you can still actually make certain claims about how these types of things compare in order to try to understand. One that I think is particularly interesting is comparing advancements to risk reduction. To some extent, you could think of this as like progress studies versus existential risk, which is more important, or something like that. So the idea would be, let's compare these things, and the maths is a bit confusing, but ultimately there's a kind of annoying fraction on the right-hand side, but I'm just going to put that in gray because that fraction, it's hard for it to be very far from 1 if you go to the effort of thinking about what it means. And you kind of end up with a situation where in order for an advancement to be more important than risk reduction, you need to be advancing by a similar proportion of all time to what the risk reduction is. So for example, suppose that we could live for 1 billion years until the Earth is no longer habitable, if we don't go extinct prematurely. And we advance, and let's suppose that you could reduce the risk by 1 millionth. Okay, so you have an extra 1 millionth chance of survival. Well, 1 millionth of 1 billion years is 1,000 years. So the equivalent amount that you'd have to advance progress is 1,000 years in order to be competitive with a 1 millionth existential risk reduction. And so I think that that's kind of illuminating. It seems quite hard to actually advance progress by 1,000 years. Seems to be impossible even for a whole lot of influential people trying to act in the world to do it. Whereas lowering existential risk by 1 part in a million may well be achievable by the community of people interested in this at the moment. So what I would say though is that this doesn't mean that existential risk reduction is more important than trying to advance progress. Instead, and this is where it's useful to kind of reflect on the aims of all of this, instead I think it means that when you set out to advance progress, one way you might hope to be doing good is by bringing all these future points in time earlier. So you reach, you do what I've called an idealized advancement. But you might also be trying to enhance some parts of progress compared to others. Maybe you're trying to improve our moral progress sooner, or to help our technological progress, or just various ways that you could be differentially making progress on some things versus others, with the hope being that the whole shape of the trajectory gets changed in the future in some way. Maybe if we develop certain things before we develop other things, then the way that our trajectory unfolds gets greatly changed. I think that that's the hope. If someone wants to work on progress studies rather than existential risk reduction, I think that that's probably the style of argument that they need to use. And I think that this framework's useful for illuminating that they might have thought that they could use the argument that if you get everywhere a little bit sooner, you get a huge amount of value because you do this, but actually it doesn't work so well. You can also have combinations of these things. It's actually very simple kind of linear combinations. I won't go through the details. But I'm not that sure if building everything out of a factor of how much of each of these 4 different stretches and movings of the thing you have, I'm not sure how helpful that is. I think that the main use of these things is not to build a complex model out of them that will kind of solve the value of the future, but rather just to have names for these things so that people can have conversation about them and try to say, I'm aiming not at an advancement, I'm aiming at a speed up. What I'm trying to do is to permanently change the rate at which we proceed. And the other person can say, oh, now I understand what you're trying to do and why you might think it's so important. Simple, quick analogy here as to explain some of that is that all of my graphs were very schematic. They weren't attempting to be to scale. And I think that that's fine. I think supply and demand curves are like a useful analogy to that in economics, where you get these curves that, again, not meant to be to scale. They're often drawn like this as completely straight lines. Everyone knows they're not really straight. But the idea is that then you can shade in certain areas and refer to certain bits, and to notice how those bits change sizes as the things move around. And people have discovered many different insights and qualitative ideas like dead weight loss and so on by thinking about that. That's what I'm going for. Finally, just a little kind of advertisement or something for further work. The way that I dealt with risk in this is very simplistic in that it's all the risk happens right now, or very soon from this perspective. In reality, there would be some kind of risk unfolding over time. I guess the other place risk appears in my version is that there's some endpoint where we all die, and maybe that was due to a risk eventuating at some stage. But there's a kind of artificiality about it. And what would be nice is instead to have perhaps an unending curve of value over time, which shows the value humanity would have at that time conditional upon surviving to that time, and then combine it with a survival curve, which is a curve that starts at 100% and drops and is the chance that we're still alive at that time, or that we still have our potential available to us at that time. And then you can also, another useful device one thing to notice is then the expected value of the future is actually just the integral of the product of those two curves, and that behaves quite cleanly mathematically. And then you can actually do some other stuff. There's something called a hazard curve, which is quite useful, which shows the amount of kind of risk drop at any time, conditional upon having got there. In this kind of example here, there would be like a precipice type time, and then a bit later, an even worse one. That's what's going on there, leading to these bits where there's huge amounts of hazard at 2 different times in this example. And then you could also start to ask questions of, maybe if we advance progress and we shift this curve earlier, so we reach all of these points earlier, maybe that also shifts the hazard earlier. If we're trying to imagine that we get to those stages of civilizations, a century earlier, presumably the risks from those technologies would arrive earlier as well. And then you can actually analyze what happens if you shift this hazard curve earlier. And it turns out it's actually quite easy to analyze because it turns out that the amount of existential risk is to do with the area under the hazard curve, just as it was previously to do with the area under this green curve. So everything actually turns out surprisingly clean, and I'm kind of still working on that stuff at the moment. So yeah, that's just my advertisement for where I'm thinking at the moment of developing this. But ultimately, this was about my take on long-term trajectories for humanity. I'm trying to play into that literature of other people who've been thinking about it. And to try to, in particular, think about different long-term interventions and to try to understand how to classify and compare them, trying to be extremely general. I mean, Leopold Aschenbrenner has an interestingly, similarly flavored paper, but it's all within the realms of a complex economic model, and I didn't want to have to make any such assumptions. Which, yeah, and that's it. So happy to answer some questions.
Thank you very much, Toby. We have about 15 minutes, so I'm just going to dive into a bunch of questions. So first of all, I kind of wanted to talk a bit more about the purpose and how we can use the model that you created. So I guess you talked about how it's very useful for providing names for certain things and sort of clarifying and giving us a bit of a vocabulary for discussing potential future interventions. I was wondering if you've thought a bit about how it can be used to talk about the value of like past things that have happened in humanities history as one particular area, and another thing is whether we can use this to talk about things that would reduce the value of the future, and so sort of risk increases or like slowdowns, that kind of thing.
So on the second one, definitely. In fact, if you basically just put a minus sign or divided by, just have factors that are less than 1 instead of greater than 1, that all of those ideas cleanly turn into their negatives. I can't remember what my names for them all were, but delays and slowdowns and so on. So you can definitely do that. I think that if you look at some things like, say, the agricultural revolution or the industrial revolution, they don't exactly cleanly fit into this, but they do show that you can have times that lead to pretty radical changes on the trajectory. I think that they are both examples of things which have been, in these terms, some kind of speed up and then mixed, but it's not just that things got faster. There's a bunch of things that just would never have happened if we were pre-agricultural forever. The scale, humanity wouldn't have reached its current levels of power at any point without that. So it's also been some kind of enhancement, at least in terms of capabilities, whether I think also in terms of value, but that's maybe more debatable.
Okay, yeah, that makes sense. I also wanted to compare it and contrast it with some other frameworks that people have put out. So some people may be familiar with what Will MacAskill describes in What We Owe the Future, a sort of significance, persistence, and contingency framework that I think Will and Terry Thomas and Aaron Valander proposed. And so this talks about the sort of the size of a change, how long it will last, but also how contingent it might be and how sort of likely it is that it would have happened anyway.
Yeah, so this is, I love that framework. This is kind of significance and persistence. Well, in fact, it's only really looking at things which are fully persistent, which I call lasting changes. But it's not addressing contingency. And so that means that it's actually somewhat harder to have examples of these things than you might think. If you're trying to say, what's the actual value of producing this change compared to the status quo? It's hard to know what the status quo is. Maybe the status quo, the thing happens anyway. That's what it means if something's not very contingent. But you can use it for both types of questions. Even though it would be nice to additionally have things to get into that, it is nice to know that you could ask questions such as, what if we never did this thing that we probably would have done anyway? How much better is it if we do it? Even if they're not really both on the table at the time. You can still address those questions.
Thanks. And so then there have been a couple of questions about sort of the setup of the model in general. So one of the things that's come up a little bit is about the assumption that goes into having instantaneous value of the state and then summing that up over time. Where a couple of people have pointed out that maybe some people might think that value going up over time is more valuable than value going down over time. And certainly that seems to be what people feel like about their own lives, and maybe we should think about that for sort of humanity's trajectory. Do you have a view on that and that assumption?
It's a good question. Definitely, they're effectively, I don't have to assume that it's fully instantaneous and these are really clean integrals. It could just be that it's the sum of a whole lot of discrete time periods or something like that. But it does make an assumption that value is something that accrues over time and that is roughly datable to a particular time, and also that it's separable, at least at long time scales. So what that means is that what choices we make about, say, improving or trade-offs in one time period, that if they were to only affect that time period, independent of what we do in other time periods, which if that were true, then there wouldn't be these global shape things to say that a thing going up with the same area under it and something going down is worth more. There have, though, been philosophers who've tried to look into that with the case of an individual life. And so one could perhaps try to look at what they've done and see if you could port that across. Although my guess is that actually that's not how we should be looking at it.
Yeah, does it make sense conceptually? Because I think one of the things that you do sometimes in The Precipice is use the analogy of thinking about the course of humanity's civilization, sort of using some of the same terminology or some analogy to the way that we might think of the course of one's life. So think about civilizational virtues and sort of, and think about the lost potential of humanity as this like collective. Does it feel like those? It sort of feels like sometimes in The Precipice you're sort of porting over the similar ways of looking about a life.
Yeah, I mean, I think that that's a often useful but not always useful analogy. It's sometimes misleading, but you've got to be careful. But to the extent to which it is useful, maybe that means that one should worry about this, because I think people have perhaps stronger intuitions that the shape of a life matters when it comes to individual lives, and then that would perhaps be an argument for that happening over this longer period. Yeah, as I say, my feeling is that it probably isn't, but I don't have an immediate knockdown argument.
Yeah, I mean, I guess one thing could be that sort of psychologically you can remember what happened to you in the past and like shapes how you feel about your life right now, whereas it's not so clear that like future populations will think in quite the same way about the past.
Also, if we're doing this carefully, then we're meant to have adjusted for your mental state anyway when we're drawing this thing. So if you're constantly frustrated at knowing that everything's getting worse and worse, then the curve should be drawn lower in that case, in which case it will have less area under it.
Makes sense. The other question that people had about the sort of setup of the model was around whether we should be thinking about the total value or whether we should be like disproportionately focusing on the very best or perhaps the very worst kind of outcomes and trying to affect those or pay closer attention to those particular parts of the curve.
I think that it's something like the total. I think that even if one has, there are ideas like prioritarianism or some suffering-focused ethics, which might try to give extra value to negative things or extra importance to improving things when they're worse off. I think that there's some plausibility there, but I still wouldn't just focus on like the things like that are the best or the worst. I think that it would need to be some kind of smooth effect.
And I guess it's compatible with your model to then apply some additional transformation about sort of how you might turn that into what you might care about, I guess.
Yeah.
Does that make sense?
I mean, it's. I tried to do this. There's always this trade-off between how abstract you're going to be. I've erred on the direction of being pretty abstract here, so that then there's kind of ways of reshaping. You know, for example, if you think that suppose you are a prioritarian and you think that it's not just happiness that matters, that improvements at lower levels of happiness matter more, you can actually just reshape this whole curve based on that, and then run my argument based on the reshaped curve, because I've done it at this level of abstraction.
Yeah, because it's more, the points on the curve are more about correctly representing the state of the world at that time, and so your like prioritarian instincts may apply there.
Or whatever contribution that's making to actually whether you should choose an outcome or not. It's meant to be representing that contribution, and that could be a more complex function.
Okay. And so then talking a bit more about some of the transformations, I was kind of wondering how you chose those particular transformations. It sort of seems like they aren't necessarily like mutually exclusive and completely exhaustive of all the different kinds of things that could potentially happen, in particular affecting the shape of the curve, sort of like things that could, you know, affect the peak or sort of cut us off at like no higher than this, could actually be like quite significant. Do you have any thoughts about sort of which things you picked and which things like that seem like the most important to focus on?
Yeah, I did play around with this for quite a while and have some discarded kind of set of things. These were ones that made a nice family. They're the kind of linear transformations of this curve, and that where you have this nice independence of the shape of the curve, you know, that I stressed. So you don't have to, there's not too much of a demand of knowledge in order to be able to make these types of measures. But I quite liked that idea that you mentioned, perhaps if you said there's a kind of cutoff, that there's a maximum, you know, it can never get beyond a certain point or something. That's a fairly clean kind of transformation. Or maybe you could create a minimum, a floor below which it never falls, and at least somewhat clean. I think that there might be a few others as well, but they're a bit complex to specify.
Yeah.
But there's some of them to do with, there's an idea that like if you have a bathtub, because I'm thinking about marginal changes, but you can get a situation where if there's a bathtub, you know, standard climate change analogy, there can be cases where if you slightly change the flow of water going into it, if there's no plug in there, that the bathtub then rises up because the level, water's been added faster than it leaves, and you have a very big change over the long term into the state of the situation, just from an extremely small kind of change of the other thing. And I think that there could be some marginal changes like that. For example, whether that tilt something from being in exponential decline through to being in exponential rise. Yeah.
Yeah, I think I find it hard to think of examples of things that would very clearly be sort of some of these kinds of changes, although it's possibly easier to think of things that might change the potential maximum that we could get to, or create a floor or something.
Yeah.
Maybe seems like it's easier to think of examples of those kinds of things.
And I focused here on marginal changes, so things that have to be small in some sense, but then also have to be big in some sense to be worth caring about. And so the idea is generally that it gets multiplied or by one of these big numbers that appears in the model, so that a very small thing in one direction ends up multiplied by a big thing to give something that's macroscopic. But you could also look at non-marginal changes. For example, you could have a set of stylized trajectories, such as exponential all the way, or perhaps something that's exponential, or an S-curve up to a plateau. And perhaps the length of plateau, you could parameterize how big that is, the plateau time compared to the time up to the ascent of the plateau. And then you could say, what if the plateau was at a lower height versus, what if we got to a different height in the long run? How would that compare to how quickly we get there? And you could ask questions like that. And they need not, in some cases, be marginal questions. There are some ways of asking bigger questions as well.
Yeah, and I'm interested in this sort of turning the theoretical argument and trying to identify empirically some of the interventions it might be applying to. I'm wondering how easy it actually is to sort of map a specific thing that someone might want to do in the world onto one of these sort of transformations. So if I was thinking, for example, of sort of like longevity research, or if there was something that could extend people's healthy lifespan by a couple of decades, it's actually just very unclear to me, like, which, if any, of these transformations that most likely would be represented by.
Yeah.
Do you have a sense of this, of like how hard that is?
Yeah, I think it's pretty tricky, and these aren't designed, I don't think you should be assuming that everything you can think of changing is going to fall into one of these categories. I think a lot of things will be none of these, and in fact will have no long-term or predictable long-term influence over the future, but that's fine. If you did something like increasing people's lifespans by a couple of decades, then the main question is, how long would it be before we did that anyway? It could be, like with some things, that we always stay a couple of decades further than we would have been or something, which could be interesting. But probably we're accelerating one, I guess it would have big impacts for the individuals at the time, but it's only one thread of all of the types of human progress that would be accelerating by some number of years. And overall, that's probably like a very small version of an advancement. Yeah.
Compared to things that affect all types of progress.
Yeah, and maybe the example with progress studies was kind of useful because it was a bit of a negative result, but it was showing that to the extent to which the point of it is to get to all times sooner, it could well exceed many different kind of like near-term interventions, but it's not going to beat existential risk, I think. But then that can help them to notice that the types of ways they should be thinking and conceptualizing progress studies are probably more to do with changing the shape of the curve because of how some things happen sooner compared to other things. So it can be useful for that, for showing, if it was only aiming at this kind, it would get defeated by this other thing I could be working on instead. So the only version of this that's going to be competitive would be a version that also tries to do this. That's the kind of reasoning that I'm hoping to see.
Yeah. And I guess lastly, are there any other kinds of key takeaways you think that the EA community or the long-termist community should be thinking about? So perhaps we've mostly been focusing on risk reduction, but is it perhaps the case that enhancements or something are a bit more more neglected, or like should deserve some more attention?
They probably are a bit. Ultimately, one of the reasons I tried to look into all of this was I thought Nick Becksted's argument was good, that there'd been very little attempt to actually compare in these cases. And so I wanted to try to open that up and to try to see how much room there is for good long-termist interventions that are not focused on existential risk reduction. Overall, I feel that the answer will be that existential risk reduction still is really the key aspect of our time within the world of long-termist interventions. Maybe in 5 centuries' time, when we've kind of got this under control, these other ones will be more important. But I think it's still an open question, and I wanted to try to help provide some tools to let other people answer that question.
Okay. I think those are all the questions that we have time for in this session, but if you do have other burning questions for Toby, he's going to be doing office hours directly after this over in East Mall 5. Fantastic. So join me again thanking Toby Ord for the talk today.